Hi everyone, in this video we're going to be learning about bearings. In particular, we're going to be learning what a bearing is. And for that, I'm going to need 2 points. And I'll draw them here. I'll say point A, right there, and a second point B, right there. And on the left-hand side here, I'll write a little bullet point list to define a bearing. So I'll say a bearing is 2 dots. Well, first of all, a bearing is an angle. And it's always expressed with 3 digits. Always expressed with 3 digits. Here's what I mean. Let's say we had an angle of 37 degrees, then when working with bearings, we'd say that's 037 degrees. Or let's say we had an angle of 5 degrees, then with bearings, we'd say 005 degrees. And of course, if we had an angle of, say, 137 degrees, then when working with bearings, that would still just be 137 degrees. So that's the first thing. A bearing is an angle. The second bullet point I'll add here is that that angle is always measured clockwise, from north. And the fact that a bearing is always measured clockwise from north is extremely important, so do make a note of it. And the final bullet point I'll make here is that a bearing tells us how to navigate from one point to the next. And what I mean there is, imagine if we were in a ship at sea and we were at a point A. Then to get to point B, we'll speak of the bearing of point B from point A. And so I'll just write tells us how to navigate from one point to another. And I said navigate here, but I could say how to get from one point to another. Okay, now that we've written all this, let's go back to the 2 points I drew here. The bearing to get from point A to point B, we'll speak of the bearing of B from A, is the angle measured clockwise from the northern line or north line which I draw at point A, and I always draw the northern line vertically upwards from a point, and I label it N for north, to the line segment joining the 2 points. In other words, the bearing of point B from point A is this angle right here, and I'll go ahead and call that angle alpha. And so going back to imagining that we were in a boat at point A, to get to point B, we would have to sail at an angle alpha measured clockwise from north, and we do that with a compass. And now, imagine if we sailed up to point B, so we're now at B, and we needed to sail back to point A. Well then in that case we would speak of the bearing of point A from point B. And careful, it wouldn't be the same as alpha. Indeed, to illustrate it, I place myself at point B, and I draw a northern line or north line pointing upwards from point B, and I'll label it N for north again. And then the bearing of point A from point B is the angle measured clockwise from the northern line at point B to the line segment AB. So that's that yellow angle there, which I'll call beta. And this quick illustration shows us quite clearly that the bearing of point B from point A, that was alpha, isn't the same thing as the bearing of point A from point B, that was beta. And in fact, there's a nice relationship between these 2 angles, which is worth knowing. And here it is. If the angle alpha is an acute angle, so I'll just say is acute, or if it's an obtuse angle, or obtuse, then the angle beta is equal to alpha plus 180 degrees. On the other hand, if ever the bearing or the angle alpha is a reflex angle, so I'll just say if alpha is reflex, then the bearing or angle beta will be equal to alpha minus 180. Remember, a reflex angle is an angle that lies between 180 and 360 degrees. Now, these 2 results are definitely worth knowing, so do make a note of them. And in fact, here's a quick example. Let's say I had a point A here and a point B right here, and I'll draw the line segment joining A and B. And let's say the bearing of point B from point A was 70 degrees, so I'll write that as 070. Remember, a bearing is always expressed with 3 digits. Then, because 70 degrees is an acute angle, we could quickly use this formula here to figure out the bearing of point A from point B. In fact, let's quickly illustrate that. I'll draw my northern line at point B, so that's my vertical line going upwards at point B. The bearing of point A from point B is this angle right here, and because the bearing of point B from point A is 70 degrees, we use this formula here to state that this yellow bearing is 70 plus 180, and that's equal to 250 degrees. Another example, let's say I had a point A right here, and a point B right there. And I'll join those 2 points with a line segment. And in this case, I'll say that the bearing of point B from point A, so that would be this angle here, is 240 degrees. Then, because 240 degrees is a reflex angle, we can use the second formula we have here to quickly find the bearing of point A from point B. And to show that, let me draw my northern line starting at point B, going upwards, and that's the northern line. The bearing of point A from point B would be this angle here, measured clockwise. And using this formula for reflex angles, we can state that it's equal to 240 minus 180. And by all means check, but that's equal to 60 degrees. And since it's a bearing, we'd write it as 60 degrees. Okay, so at this stage, we should have a pretty good idea of what a bearing is. It's an angle, which is expressed with 3 digits. It's always measured clockwise from north, and that angle tells us how to navigate from one point to another. And finally, we saw here how to get a bearing of a point A from a point B, given the bearing to get to point B from A. Now, to finish this video, let's quickly look at an example to show us how bearings can actually help us navigate from one point to the next. We're told, starting from a point A, Sarah cycles at a bearing of 72 degrees for 8 kilometers to reach point B. She then cycles at a bearing of 150 degrees for 10 kilometers to reach point C. Finally, she cycles at a bearing of 210 degrees for 12 kilometers to reach point D. We're then told to make a labeled illustration to show Sarah's trajectory. In other words, we need to draw the path Sarah cycled along. So let's go ahead. I'll start right here. I'll place a point A. There we go. And from point A, we're told that Sarah cycles at a bearing of 72 degrees for 8 kilometers. So to illustrate that, I start by drawing the northern line pointing upwards at point A. There we go, and I'll just label that N for north. And from this northern line, I measure a 72-degree angle going clockwise, which I'll say leads to there. And I then draw a line segment, like so, which is 8 kilometers long. There, and I reach point B. So if I just label this angle here is 72 degrees, and the length of this line segment is 8 kilometers. Sarah is now at point B. From point B, she cycles at a bearing of 150 degrees for 10 kilometers to reach point C. Okay, well, starting at point B, I draw a northern line again, like so, pointing upwards, that's the north. And I now measure clockwise an angle of 150 degrees. Now, 150 degrees is more than 90, so I'll say it's roughly here. And I draw my line segment, which should be 10 kilometers long, so a little longer than the previous. There we go. That's point C. And if I carry on labeling this, so let's see, that was the bearing of 150 degrees. In fact, I'll underline that in the text as well. There we go. That was 150 degrees. And the previous one was 72 degrees, which was given right here. The line segment BC here has length 10 kilometers. So I'll just label that. That's 10 kilometers. Done. Okay, Sarah is now at point C, and we're told that finally she cycles at a bearing of 210 degrees for 12 kilometers to reach point D. So to illustrate that, I place myself at point C and I draw a northern line, like so. That's the north. Now from the northern line, I need to measure an angle clockwise of 210 degrees. And that's more than 180 degrees, so I should be roughly over here somewhere. And she cycles at that bearing for 12 kilometers. So I'll say that's roughly something like this. There we go. That's point D. And the bearing she cycled on, remember, was this angle right here, and that's 210 degrees. And there we go. That's how we can map out a trajectory using bearings. And so hopefully now you have a better idea of what a bearing is, as well as what it can be used for. And that's it for this tutorial.